From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez.
And we initially chose to go look at materials into the filament part of 3D printing because it was believed that was a little bit more open marketplace at the time. Powders was a pretty closed market, if you will, and filaments were a little bit easier and quicker, maybe if you will, to get qualified. But soon figured out if you're trying to sell filament, people want to buy filament by a box, by a spool, not by a truckload, right? So they also want to pay using a credit card or PayPal. That's not part of Eastman's business model, was to take those kind of small orders. So
that was Bill Heise. Bill spent over 30 years at Eastman Chemical. His final role was leading their corporate innovations group's development and execution of an additive manufacturing strategy. Currently, Bill is a team member of 3Degrees and teaches in the Department of Management and Marketing at East Tennessee State University. He joins me today to talk about progressing an additive manufacturing strategy through a large organization. All right, welcome to the show, Bill. Why don't we just kind of jump right in and give a quick introduction of yourself and your background.
Sure. Thanks, Mike. So my name is Bill Heise. My background is a chemical engineer by training, but spent 28 years at Eastman Chemical Company, and through those 28 years had a variety of assignments, mainly in business development, new product launch, technology management type roles. And one of my last roles before I retired from Eastman was in the area of 3D printing, and it was interesting. The CEO was asked by one of the board members, hey, what's our strategy around 3D printing? And at this time, probably back in the mid 2000s, hadn't really thought about 3D printing much as part of our strategy. It was pretty much a lot of hype. If you're familiar with the Gartner hype curve, it was probably at one of the peaks of hype. And so, as things typically do in a large corporation, things trickled down and landed on my desk and said, Bill, please, what should our strategy be around 3D printing? And at that time, I didn't know how to spell 3D printing. So it was an interesting project to get engaged in. And so I spent some time, several months, looking into what could Eastman do or in the 3D printing world.
And for those who aren't kind of familiar with Eastman, primarily kind of a chemical company, for lack of a better description.
I would call it more of a materials company, Mike. Okay. Not just basic chemicals, although that is part of their business, but a lot of specialty materials, polymers, specialty polymers. In the past, when Eastman Chemical was spun off from Eastman Kodak, they did have quite a few commodity polymers in their portfolio, like polyethylene, polypropylene, PET. And over time, Eastman Chemical, once it became an independent company, divested a lot of those businesses and became more of a specialty materials, specialty polymers company.
Got it. And for them, I'm assuming, so used to selling materials by the train car versus with kind of 3D printing.
Orders, lots of pellets going into a rail car or even in by truck. So when you come talk about 3D printing, where's the volume at? So that was an issue that we had to kind of take into account in our strategy. Is how to position products, and that was the initial strategy that we chose to go forward with. Is what existing products would we have that would be suitable in 3D printing applications? And as you know, 3D printing applications varies a lot based on the process. Is it a powder? Is it a filament? Is it filled? Is it unfilled? So there's a lot of different options to consider. So one of the first things that we did was hire a consultant, Dr. Mike Vasquez, and helped us kind of weave our way through what should our strategy be. And we initially chose to go look at materials into the filament part of 3D printing because it was believed that was a little bit more open marketplace at the time. Powders was a pretty closed market, if you will, and filaments were a little bit easier and quicker, maybe if you will, to get qualified and but soon figured out if you're trying to sell filament, people want to buy filament by a box, by a spool, not by a truckload, right? So they also want to pay using a credit card or PayPal. That's not part of Eastman's business model, was to take those kind of small orders. So we quickly realized we need to be partnering with somebody who's already figured out that part of the value chain and who could actually take pellets, make a good high quality filament, package it, and take orders, deal with all the different colors that were required, etc. So we partnered with a company called Color Fab in the Netherlands. And once we decided to go forward with Color Fab, we had products on the market within 9 months, which is a pretty quick development program, joint development program. As long as I'd been at Eastman, that was probably the quickest commercialization of a new product that I'd ever been experienced with.
I'm always fascinated with big companies because I worked a little bit at 3M, but as an intern, but like the mechanism of how these types of initiatives get started and kind of what how does it just you said the CEO kind of called down the chain and said like, hey, what are we doing in this? But kind of what happens from there? Do you guys assemble a team? Was that your primary role, was kind of new technology scouting? How did it actually kind of get moving with?
Yeah, that's a good question, because typically for something new and unknown like this project was at the time, well, don't spend any money. It was kind of like, we don't want you to spend a lot of time and money on this. So I got a few folks that I knew would be interested in this, kind of out of the box thinkers, and assembled a small team and started looking at, well, how can we get our materials tested for fitness for use outside of Eastman? Because we didn't have the equipment, we didn't have the capability to make a high quality filament to be tested. So we quickly learned that we're going to have to partner with somebody else to be able to do that. And there's a downside to partnering with somebody else. You're going to be sharing value, but the upside is it's lower risk up front and lower cost, because you're sharing the cost as well.
Yeah. And this was, by the time you were involved with the 3D printing stuff at Eastman, you had been with the company for a number of years. Was there kind of a large difference between what you saw in 3D printing versus other industries or projects that you had worked on? Was there any similarities that you'd seen with emerging technologies?
This one had a lot of new aspects to it, which made it interesting, actually. It wasn't the traditional processes that you think of polymer processes: injection molding, extrusion, film extrusion, etc. This was a totally new type of process. And the question I got a lot was, well, is this really going to be here, or is it just a fad? Is it just making toys and trinkets, or will it have some kind of industrial application? You don't ask those kind of questions when you're talking about a new material that's going to go into packaging or bottles, for example. So it had there were a lot of naysayers, if you will. That's probably typical at a large company when you're trying to look at some disruptive technology application. You just kind of have to, we're taking a low risk here. I'm not trying to commercialize a new polymer. I'm trying to look at an existing polymer and see if it has a different application, which, by the way, should have a higher value than what we're selling into the current applications.
Right. Price per pound is
Yes,
far
price
and
per
away.
yes.
Yep.
So it's fewer pounds, but some pounds that you could get a lot higher value for, right? So that was the selling point was, hey, I'm not spending a lot of money. We're not having to commercialize a new resin. Just give me some time to see if there's a new application here. And that's how I had to sell it initially, just to be able to spend some resources looking. If I said, look, I'm going to develop a brand new resin for this, and the volumes are going to be fairly small, that probably would not have been a successful project.
So it's a lot on you. How do you frame it with kind of
Yes.
other parts of the company to say, okay, give me 2 to 3 years, and we think we can get to this point, and here are some of the markers where we can kind of show that we're making progress.
Yes.
Yeah, that
Yes.
seems to be common in companies I've certainly talked to. With you get the call from high on top of the mountain saying 3D printing is our
Yeah.
competitors using it, or there's a new material. Why aren't we doing that? And then it's always really interesting that kind of that same conversation comes up over and over again. There's someone that kind of takes it on as the main cheerleader and main kind of
Be a
go-getter to in the
champion. And it's funny how larger companies tend to respond better to a threat than to an opportunity, if that makes sense. Like you said, oh, our competitors are doing this. We need to look into this. That means they're threatened by it, or oh, this is a new space we've never looked at before. It's harder to get folks excited about an opportunity, it seems like, than a threat. But I think it was successful what we worked on, and once we had a filament material, actually we commercialized several different materials into the filament market. Then we started looking more into the powder market, and the reason powder is probably more of interest is the volumes potentially could be higher. It is considered probably a little bit more on the industrial side of 3D printing. You're not going to have a home-based powder 3D printing unit. That's going to be more at corporations, right? So powder became the kind of the next focus area that really was perceived to have a lot more potential than the filament market.
right. And I'm sure one of the challenges along kind of both the filament and the powder space is you're creating new materials and you have to sell within Eastman kind of the idea of 3D printing, but then my sense is that you're also trying to build some sort of market with customers, whether they be existing Eastman customers for other applications or other resins, but also going to completely new sectors that you may not be 100% familiar with.
Yeah, and kind of a side benefit to kind of go with what you're talking about here is a lot of conversations with existing customers, even about talking to them about what their 3D printing strategy was, and here's what we're doing. It invited new conversations. Oh, Eastman's now viewed a little bit more innovative than we used to think, and you could now bring in a prototype of what a package could look like with a new material that you couldn't do before, right? So you could do more things for customers, and it led to more conversations other than just price volume, which is what our sales folks, yeah, they have to do that, but they're always looking for opportunities to have more conversations with more people at the customer level. So
So changing the perception a little bit of the company.
yeah, so it actually had a side benefit there of having uh, more this Eastman's being innovative here. That's something we should pay attention to versus and invited new people into the conversation at customers that you may never have been able to talk to before. So that was a pretty good side benefit that we did not appreciate at the very beginning.
Yeah. And how much of that kind of, I guess, decision making on kind of where, I mean, you guys have a portfolio, or Eastman has a portfolio of dozens, if not hundreds of different materials. And then you're balancing that with what might actually work in a printer along with what are people looking to buy in the space. So how did that equation work out?
That's a great question. So we spent a lot of time talking to folks who were using filaments, and at that time it was primarily PLA and ABS were the two primary materials used for filaments. Um, and talk to folks about, what do you like about these materials, what do you not like, and kind of did that kind of background market understanding so we could look at what features we could offer to address the deficiencies in those materials. For example, PLA is quite brittle, and yet it's easy to process, right? That's why people use PLA, and a lot of initial printers were designed around PLA as far as temperatures and those kind of things. ABS, better material properties, but had the issue of giving off styrene as it's being processed and melted, and so there was a safety concern, an odor concern using ABS. So we were able to come up. Our initial material was able to have better properties than PLA. Maybe somebody even argue is as good, if not better, than ABS, but did not have the odor and material safety concerns. So we were able to meet a market need that at the time wasn't being met.
And that's probably the advantage of a materials company, right? I mean, especially
Exactly.
early on in the 3D printing space, most of the materials were prototyping. Like if it worked in the machine, like that's great. Like the printer companies themselves didn't have huge materials teams doing development day and night, and kind of Eastman and companies similar, that's their business. They have DSCs
Exactly.
all around every
Exactly.
office may come with a DSC, right? And in terms of the characterization and just
Yeah.
insight about the raw polymer and things you may not be typically thinking of from a commercialization perspective.
And Eastman being in the packaging and uh, food contact kind of space had a lot of materials that had FDA approvals around skin contact and those kind of certifications. So that was a big help. And our partner Color Fab on the filament side already had several relationships with OEM printer companies where we could get in very quickly and test the materials on their equipment. One thing that was a bit of a surprise was just because your filament runs on company X's machine doesn't mean it's going to run on every other filament produced filament printer. So we had to test a lot of different printers, which took a lot more time than we had envisioned. It's not like injection molding. If your pellets work an injection molding machine, you don't need to test every single injection molding machine out there. It was a little bit different for the filament side.
Yeah, and I think the other thing too that I'm guessing is even today is quite challenging is the fact that, I mean, each machine is different, but the business model for each printer manufacturer is slightly different. So there are some systems that are closed, and you can't. I mean, you have to have a more thorough negotiation with the machine manufacturer because their customer who's buying the filament can only buy through them, and versus some of the other printers that are more open. So
Yes,
it's not like injection molding where you can throw whatever you want into your.
exactly. It was a little more open with filament than it was on the powder side.
Yeah,
But you're right. There were some filament uh, uh, printer machines that we were not able to penetrate initially.
right, right. And what was your general sense of uh, as you got into the 3D printing space more and more, started doing a lot of interviews with customers and or potential customers and talking with the printer manufacturers? What was your general sense of the industry from a maturity level? Was it kind of what you expected kind of from going in and starting the initial exploration and project, or was it something different?
Well, I can remember going to the first AMUG meeting, the Additive Manufacturing User Group. It's an annual conference, and I was surprised at the lack of standardization, might be the right word, or lack of consistency. It was still fairly new to folks about materials, and I think, in all fairness, the probably the printer manufacturers were concentrating so much on getting a printer, all the mechanical engineering stuff done. Not much attention was paid to the material side. So materials kind of came later after the hardware, if you will, and so materials were having to play catch up. And so I was kind of in the midst of this, what do we do from a new material standpoint? Because, some of the printers couldn't go to a high enough temperature, for example, and would need a new nozzle or whatever. And a lot of folks, instead of coming up with a new polymer, said, "Well, we'll just add a little bit of additive, whatever that additive is, into the polymer to change the properties." So you see a lot of PLA with glass fibers or glass beads or whatever, So compounding into the PLA, but you still had a PLA-based polymer. So there were a lot of barriers for new materials to be developed and spec'd into the filament space that we didn't appreciate initially. So to answer your question, I think it wasn't a mature industry at all, and that has good and bad, because if it's not mature, that means there's maybe space for you to get in. But I was able to convince my management, hey, this train is leaving. We either need to be on the train or we're going to miss the train. So let's get on the train and learn as we go. And again, not have to take a lot of risk. We weren't putting a lot of capital in the ground to participate in the market.
Sure. Yeah, I think that's in some ways it's certainly improved, and over the last few years, I see there's kind of similar to Eastman. There's a trend of larger chemical and materials companies getting into the space, both on the polymer side and the metal side, and trying to figure out what that right balance is. I think I still see many of these companies struggle with that question of, we're not selling train loads or cartons of material. I think that's even at a enhanced kind of markup costs. I think that's a hard paradigm for companies and the people in those companies to think through.
I think you're right.
Yeah, it'll be fascinating to see how it continues, because as you were saying, it goes hand in hand with the machine manufacturers, where, okay, if they get bigger machines or faster machines and you can use more material, then we're starting to kind of change that conversation a little bit. But right now we're in a little bit of that. There's some examples of high volume, but most of it's low, medium volume, and the material consumption is still quite low.
Well, and on the powder side, Mike, their business model was they made a significant chunk of their revenue by selling their own powder. And if you bought powder from somebody else, you potentially were going to avoid a warranty or avoid a maintenance contract. And at the time, the users did not have, the customers and users did not have enough experience to be able to say, well, I'm willing to take that risk. Because, they spent a lot of money for these machines and didn't want to endanger that. So they had to use the powder that was supplied by the printer company. I think over time, as people get more experience, are more comfortable with the technology, willing to try some new things, will be better as far as the material, using different polymer materials in the SLS type of machines.
Right. I mean, once you have a setting for a nylon 12 that you like, changing over to a elastomer or a PA6 or PEEK or something like that is not a trivial task.
Yes. And so we chose, as part of our strategy, to partner with a couple universities that had powder machines that they were willing to basically didn't care about the warranty. We're basically open to trying new materials, because how else are you going to be able to test? You can have a great powder and it looks like it flows really well, but until you put it into an SLS machine, you have no idea what kind of properties you're going to get, and how well it's going to perform in the bed. How much recycle are you going to be able to have? Because that's a big issue that folks complain a lot about, is the recyclability of the powder that doesn't get incorporated into the part. So that was the focus of the polymer development that we worked on at Eastman, was a fully recyclable powder, and a little bit different properties than what you get from the nylon 12.
Yeah, changing up that whole cost calculation, because if you're throwing away a third of the powder that you're using in any build, that becomes a pretty expensive venture on
Exactly.
the customer side. And not to mention, I mean, having used a lot of SLS systems, the throwing away just tons of powder into landfill was never a good feeling.
Exactly.
So excellent. I think I know we'll have you on a lot more on the podcast, but and I think there's probably a whole entire episode we can divulge into the science and the nuance and materials discussion around kind of what's a good polymer for sintering. So I think we could go into much more detail there. So as we kind of wrap up here, I guess maybe just we'll spend a few minutes kind of talking a little bit about what you're doing now. I know, again, for listeners who are not familiar, Bill does work on the 3Degrees team on various projects from time to time, but you're also teaching. So what are you, what's the latest there?
Yeah. So after I left Eastman, I took a role in the business school at the East Tennessee State University. It's a public university in Johnson City, Tennessee, where I'm actually working and teaching in business strategy, which is kind of interesting, because that's a lot of what I did at Eastman. Kind of not really knowing what I was doing, but now kind of figured out what I should have been doing, and I'm teaching the classes mainly at the MBA level. And one of the things we do for the capstone project is we work on strategy projects for the local community. So I feel like it's fun working with the students, working on strategy projects, and the students love working on a project that is a real problem, not just one that I just made up. And then still working with 3Degrees. Love working with companies to help them figure out what their strategy should be. Who should they partner with? What materials should they be looking at? What processes should they be looking at in 3D printing? And where is it going to make the most benefit for the time and resources it's going to take? So to me, those are all fun projects to work on. And I appreciate, Mike, you let me be a part of your team.
Fantastic. And I think the one thing you did forget to mention, and maybe most important now these summer months, you're a master smoker. So if you need recipes for what I think the latest, your favorite is salmon, right?
Yeah, salmon is kind of my go-to for now in my smoker. But it's kind of funny. People ask me what I do once I retired from Eastman. I said, well, I took up smoking, and you get some strange looks when you say that. Then you have to quickly add meat and fish to that.
A much tastier version. Awesome.
But yes, that typically the family is asking at a major holiday event, they want something that's smoked. So that's something I enjoy doing.
Awesome. Well, appreciate the time, Bill. Thanks so much.
Thank you, Mike.